Hey, there's one more thing I want to talk about with formulas, and it's how to solve a formula for a given variable. This happens a lot. It's not useless. In fact, when you go forward in math, you're going to have to do this quite a bit. You're going to get a formula, and it's going to work, but then you're going to need to solve for a different part of that formula to use it in a different way. The mechanics of that, and what I want you to get out of this, is that the mechanics of this are exactly the same as solving linear equations. It's the same stuff. Use what you know about linear equations. Not so much simplifying, but getting rid of fractions, combine like terms if you have to, isolating the variable, uh, getting rid of pieces that are connected by addition through subtraction, and subtraction through addition, getting rid of pieces that are connected through division by multiplication and multiplication by division. In other words, using those inverse operations. These are done the same way. Now, they look more intimidating because there's a lot of moving parts to it, a lot of stuff going on. But I'm going to give you some techniques on how to solve this. So your goal is to take a formula that someone gives you, like me, and solve it for the variable I tell you to. Right now, let's go through this real quick and determine what variables these are solved for. Firstly, here's a formula. Hey, it's an equation, and it's solved for s. S is all by itself on one side of the equal sign. The next equation, it's not solved for a variable. All the variables are wrapped up. This would be kind of solved for 5. 5 is the only thing by itself. This is not solved for any variable. The next one, that should look familiar actually. That's the formula for how you change Fahrenheit into Celsius. We're going to figure out how to change Celsius into Fahrenheit. Right now, this formula is solved for C. It's solved for Celsius. It's all by itself on one side of the equal sign. We're going to go through and we're going to solve these for a different variable. Let's look at the first one. I want you to solve that formula for the variable b. So just for some practice, we're going to solve for b. One good technique that I like to do, if you have a different colored pen or pencil or you want to switch this up, erase the variable that you're trying to solve for and rewrite it in a different color. That'll show you what's next to it that you need to get rid of. So I'm going to take my b, I'm going to write this in purple. You can see the purple. So we have now s equals a plus b plus c over 2. It hasn't done anything different, but it's let me see what I need to get rid of. I need to get rid of a plus c, and a that's being, well, b is being added to a, so a is connected to b through addition. So I need to get rid of a c, an a, and a 2. Now the order in which we do this is very important, but what's great is that I also told you this is very, very similar to dealing with linear equations. So you look at that as a linear equation and you're trying to get this purple letter, that b by itself, and you need to get rid of, wait a minute, simplification says get rid of fractions first. So we can't distribute, where there's no like terms to combine, but there is a fraction. Kill that fraction. Look, you can still do the same thing. This is just like s over 1. Your denominators here are 1 and 2. What's the LCD? Well, the LCD is, it's 2. Use 2 and do the same thing you've been doing this whole time. Multiply both sides by 2. Now, if you're wondering why we're not multiplying this by 2 and this by 2 and this by 2, it's because all of those terms are wrapped up into one big fat term with a denominator of 2. This 2 includes all of that junk. So you don't have to multiply all of it by 2. In fact, what this really means is weird. Don't let this confuse you. But what this really is that. That has a common denominator of 2. You could put all of this on one fraction. That's what somebody's done. So it's equivalent to multiply every single one of these fractions by 2, or take this enormous fraction and multiply the whole thing by 2. That works. That's absolutely fine, as long as you are hitting both sides. So remember why we do this. We're trying to get rid of fractions. We multiply by the LCD so that we can simplify all of our fractions. That 2 is gone. We've created a 1. 1 times the rest of our stuff is the rest of our stuff. On the left-hand side, we have 2s. But on the right-hand side, and maybe I'll write this back in black so that I can still highlight the variable I'm solving for. So I've used my knowledge of linear equations, we've got rid of the fraction. That's great. We're off to a good start. I still want to get b by itself. Look at how it's connected. So it's connected with A and C through addition. Let's undo that. If something's connected through addition, we want to make zeros out of it. Do you remember that? We want to make zeros out of this stuff. Does that make sense to you? We're trying to get zeros because B plus 0 is going to give us back B. We don't want ones. We don't want to divide right now because that would give us ones. That's not going to get B by itself. We want to completely eliminate the stuff around B that's connected by addition subtraction. That means we're trying to get zeros. How would you get this A to become 0? What would you need to do to your equation to make that A 0? Completely gone. Yeah, you'd have to subtract it. Same thing with the C. In fact, you can do it at the same exact time. As long as you do the same thing here. So on the right-hand side, A minus A, that's 0. C minus C, that's 0. B plus 0 plus 0, or 0 plus B plus 0, gives us our B. Now this side, it doesn't really matter the order in which you write this, it really doesn't. You can do negative A plus 2S minus C or any permutation of that. Most people are going to choose to do 2S minus A minus C. Just make sure your signs are right. You got to have a minus or a negative in front of your A. You got to have a minus or a negative in front of your C. You have to have a plus or a positive in front of your 2S. That's it, you're done. You have effectively solved this formula for B. B is all by itself, it's isolated. This is what it means to solve a formula for a given variable. You're just doing the same techniques as linear equations. They look more complicated, but it is the same stuff. Get rid of your fractions, then add or subtract, or multiply or divide to isolate that variable. Let's try two more. This next one, man, once we talked about this should be jumping off the page to you, what we have first. Now I'm going to tell you what variable to solve for. We're going to solve this for the variable z. So I'm going to erase my z just so I can get a good picture of what's going on. You see, when we do that, when we identify what side our variable's on, the side that you're trying to solve, well, the side that your variable is on is the side that you're trying to get that variable by itself on, which means you have to remove all of this crap around that z. That means that this side drives the problem. I don't care what's over here. It's just going to be affected by what's going on here. Yes, it's an equation. Yes, you have to do to both sides the same exact thing all the time. Do the same thing to both sides, no matter what. But we're always with the idea that we're trying to get that z by itself. So this side's driving our problem. What do you see first? If you're thinking about linear equations and you need to get that z by itself, the first step is simplify. Do you see something you can simplify? Do you have distribution? Do you have combining like terms? Really? Do you have fractions? Wait a minute, you mean you can get rid of fractions on that too? Yeah, the stuff I teach you, it doesn't work just some of the times. It works all of the times. So getting rid of fractions here is exactly the same idea as what we just did. Yeah, I know that's a 2, and I know that the common denominator here is y. Just take y divides y. 1 divides everything. So our LCD, it's weird, but it's y. Now, we did this over here. We multiplied every term. This was one big fat term. This was one term. We multiplied every term by the LCD. LCD just happened to be 2. So we multiplied every term, big fat term, by 2, and the other side by 2. We have 3 terms here. We're going to multiply every single term by the LCD of y. Try that right now. See how this looks. It looks weird, but it's pretty cool. If we multiply by y, remember the idea. A little recap for you. We're multiplying both sides, but when you multiply both sides by y, this side has to distribute. What that does is that it effectively multiplies every single term by y. Here you didn't have a distribution concept. You multiplied this side by 2, it affected the denominator straight up. That's one big term. Now, does anything simplify here? Well, look at your denominator. If you don't have a y down here, there's nothing to simplify that y, and that's okay. Divided by 1 doesn't change anything anyhow. We have 5y. Can you simplify this fraction? Well, heck yeah, that's why we did it. When you multiply by the LCD, every denominator has to go away, has to become 1 actually. So y divided by y gives you 1. 1 times z, you're left with just z. Y divided by y gives you 1. 1 times x, you're left with just x. Now keep in mind, we're still, I'm going to write this in a different color, we're still trying to solve for z. Keep in mind the variable you're solving for. That drives the problem. It tells you what to do next. We're almost there. We have an equation. We have our z. We're trying to get this variable by itself. Look how it's connected to something else. It's connected through addition. With addition and subtraction, I'm trying to get zeros, not ones. With division, I'm trying to get ones. I'm trying to get zeros because 0 plus z, good. Give me back z. How do I get rid of the stuff connected to z? Try it on your own. Well, I want to keep z. I want to get a 0. I want this to completely disappear from this side. What I do to one side, I have to do to the other side. X minus x is 0. 0 plus z is z. That's why we want zeros with addition subtraction. It doesn't, you add 0 to a number, it doesn't change the number or variable. On the right hand side, hey, you got to do the same thing. So we have our 5y minus x. You're done. That's completely solved for z, the variable I asked you for. The last one, there's only 2 variables. One is Celsius, C. That's already solved for C. The other is F, for Fahrenheit. Let's see how we can solve for Fahrenheit. Now, there's a number of ways to do this. I'm going to give you my best way. The best way that I know to do this problem is to deal with what I've told you the whole time. What I've told you to deal with the whole time is to, in equations, get rid of fractions first. You go, wait a minute, that's a fraction connected to something else. Yes, and this is I wouldn't say tricky, but it's kind of a cool technique. Do you remember how with like 5/9 x, you could make that 5x over 9. Do you remember that? How we can always float that variable up to the numerator? Well, you can also float anything multiplied by a fraction to the numerator. That's kind of cool. So what I'm talking about here is, instead of having x float to the numerator, have this entire expression float to the numerator. That's legal. Just like moving the x up, you can move an entire expression that's multiplied by a fraction to the numerator. By the way, I want to say this. You can do this in a number of ways. You could multiply by the reciprocal right off the bat, kill the whole fraction. That's okay. In fact, that's basically what we're going to be doing right now. So I want you to solve for f. I've just moved everything to the numerator because I gave you that step of write everything as a fraction. Now we have this one big fraction. I'm going to highlight the variable I'm trying to solve for. I'm trying to solve for f. My goal in life is to do everything that I can to get the f by itself, nothing around that purple letter. Also, I'm dealing with the steps I've given you before. They work all the time. Let's get rid of fractions. Hey, if this is c over 1 and this is something over 9, my denominators are 1 and 9. This is a freebie. What's my LCD? I mean, take your LCD and run with it. Let's take our LCD and let's multiply, which would be 9. Hopefully you're getting that. Your LCD is 9. Let's multiply 9 on both sides. Over here, nothing cancels. You just get 9c. On the right-hand side, look, this is one really big term. That's why we float stuff to the numerator. So you get one really big term. Your 9 divided by 9 is 1. 1 times what's left over is just what's left over. Very similar to this problem. Remember multiplying by 2 on both sides? Now we multiplied by 9 on both sides. We didn't distribute the 2 because we used it to eliminate the 2 from everything. We don't distribute the 9 because we're using it to eliminate the 9 from everything. That's the plan. Now you have a choice here. The choice is, if you're still trying to get f by itself, you need to get rid of a minus 32. You also need to get rid of a times 5. There's 2 ways to do this. You can now choose to distribute if you want to. Then you would have to add 5 times 32, whatever that is, and then divide by 5. That's fine. Or you can get rid of the multiplication first. That's how I'm going to show you here. So instead of distributing and multiplying, I'm going to undo the multiplication right now. That's perfectly legal. So if we divide both sides by 5. Division undoes that multiplication. It creates 1. 1 times whatever we have left over is just whatever we have left over. On the left-hand side, we get 9c divided by 5. You can't simplify that. And there's only one more step. Remember, we want to solve for f. We want f to be all by itself. Right now it's not, but this is the side that drives the problem. It's the side with our variable we're trying to solve for. How do you get to f by itself? Well, it's connected by a constant, and it's connected by subtraction. Just think about the opposite of whatever you're trying to undo. Right now we're trying to undo minus 32. If we add 32 to both sides, f minus 32 plus 32 gives you f plus 0. This is 0. F plus 0 gives you f. On the left-hand side, 9c divided by 5 plus 32. Now, that's the formula to change Celsius into Fahrenheit. We started with Celsius from Fahrenheit, now we get, Celsius from Fahrenheit, now we got Celsius to Fahrenheit. We're going to do one more thing though, just to be thorough. 9c over 5, can you write that differently? If you can move an expression from the back of a fraction to the top, can you move a variable from the top of a fraction to the back? And the answer is yeah. So we could write this as either 9c over 5 plus 32 or 9/5 c. Notice what we could do. If we can move the c up, we can also move the c back down. That's how you solve in a formula for a given variable. It's really useful. If you had Fahrenheit, this would give you Celsius, but if you had Celsius, it'd be really hard to find Fahrenheit from this. Now, since we solve for Fahrenheit, you just plug in Celsius and you got it. That happens a lot in mathematics, especially when you get to stuff like statistics, like finance, calculus. You deal with a lot of formulas, and your ability to solve for a variable that's given to you is really important. So that's moving forward. I just want to give it to you now so you can practice. Next time we're going to step off into a different direction. We're going to talk about not equations anymore, because we've hammered those. I mean, you guys should be really good at linear equation. That's awesome. You know everything there is to know about linear equations at this point. I'm going to start talking about linear inequalities. So things that don't have an equal sign, but we can still work with them. We can still solve these, not for one number, not for one exact answer, but for a range of answers. And that's going to be really interesting. So I'll see you next time for linear inequalities.